Assalamualaikum, we are from Royal Consultant. Want to present about Petronas Twin Tower on stainless steel based on its structure and mechanical properties. This is a few about our company. Firstly, I want to introduce myself, Nur Najwa, and my teams, Nur Shahira, Nurain Fadlin, and Muhammad Walid. This is Petronas Twin Tower that constructed by 20% of stainless steel. So, we will investigate what is the type of stainless steel that can be considered. And so, we are going to choose 316 LSS as our material construction. First objective is the role of 316 LSS, that known as austenitic chromium nickel. Next is mechanical properties that has high yield and tensile strength. Next, they will undergo corrosive process that increase the strength. 316 LSS is very durable and the temperature limit is about 870 Celsius.
Assalamualaikum, I'm Shahira. Now we proceed to methodology. Tensile test is used to determine the mechanical behavior of material under tensile load. Usually we use electromechanical or universal testing machine like STM to conduct a test. Before we get started, we need to get ready a tensile test sample which looks like a long dumbbell. In this case, we use two different 316L stainless steel. In standard appearance, 316L specimen has gauge length of 35mm, width of 12.5mm, and thickness of 1mm and 2mm of cold roll and normal sample respectively. Next, we can proceed to the experiment. First step, both ends of the sample were gripped by the machine clamp, which one of them was fixed to the place, while the other one was adding the different loads to measure the change of length. The data was automatically recorded using data software, which resulted in a graph of load versus displacement. From this graph, we can determine the tensile properties by plotting a graph of stress versus strain. This is the graph of stress versus strain for a normal sample, which we can compute the value of elastic modulus, tensile strength, yield strength, and ductility. Next, this is the data of tensile properties for graph 1.
Hello, my name is Nurain Fadlin. I present about the cold roll stress strain graph. Theoretically, cold roll is significantly stronger, harder, and it has higher resistance against tension breaking and deformation than any other types of normal or hot samples. Based on the graph plotted, we can see that the cold roll has shorter period time to fracture. The elastic modulus obtained from the graph is 214994 megapascal. By creating an offset line at 0.002, we obtain the yield strain of 0.0063 and yield strength of 1354.46 megapascal. The tensile strength of the cold roll sample analyzed is 984 megapascal and it has the ductility of 1.96.
From this, we can observe the different tensile properties between these two graphs, which graph 1 has higher elastic modulus than graph 2, and graph 1 is more ductile than graph 2, while graph 1 has lower yield strength and tensile strength than graph 2.
By analyzing the experimental results, different conditions of the same materials leads to different tensile properties due to certain processes or temperature. In general, the performance of the alloy, including tensile properties, is mainly dominated by the microstructural features, except for young modulus, since it tends to neglect microstructural features. As for strength and ductility, they are all affected by the number of grain boundaries. Grain boundaries are essentially related with grain size. The smaller or the finer the grain size is, the more boundaries will be exist. Thus, higher stress required to cause plastic deformation, and as a result, the higher the strength will become. But contrast with ductility, the ductility will get lower.
Heat treatment can enhance the mechanical properties of 316 LSS. Table 1 shows the mechanical properties of the 316 LSS. Heat treatment can be used to improve the resistance. There are 3 steps in heating treatment. First step is heating temperature. Second step is holding method. Third step is cooling method. Figure 1 shows the heating temperature of the stainless steel. Lastly is the phase diagram. Figure 2 shows the phase diagram of 31C-LSS. Heat treatment applied to 31C-LSS will remove the effect of cold forming.